Hello guys, this is day number 20 of our daily push-up challenge while solving Putnam problems, this time from the year 1959. So we read after doing the first set of push-up. Here we go. 1, 2, 3, 4, 5. Okay. And the problem, like I said, is from 1959. Given the following matrix of 25 elements, so you have 11, 17, 25, 19, 16, 24, 10, 13, 15, 3, 12, 5, 14, 2, 18, 23, 4, 1, 8, 22, 6, 27, 21, 9. Choose 5 of these elements, no two coming from the same row or column, so like reminds you of Sudoku, in such a way that the minimum of these 5 elements is as large as possible. Okay, so we want the 5 elements such that the minimum is as large as can be. Okay, so let's continue the push up. 6, 7, 8, 9, 10. Okay, so looking at the diagram, so I've noticed that, so the large elements like 25, 24, and so on, the upper 20s, are on the outer rows and columns of the matrix, right? So that like the upper 20 values. So in other words, we can look at those things because you can only choose at most 4, right, from the outer rows and columns, because there are only 4. You have two outer rows, the one up the topmost and the lowermost, and then you have 2 outer columns, the leftmost and the rightmost. So the topmost rows we can choose, for example, from these numbers, right? So these are like the large numbers. We want to pick the large first so that the last that we'll be picking will be the largest possible. On the lower most column, row, the lowest most row, I think we can pick from 20 and 21 safely, because 6, 7, and 9 are like 1-digit numbers. Those are tiny. And then on the leftmost column, we can pick between 24 and 23, right? And in the rightmost column, I think we can pick between 18 and 22. So let's write those down. So we're only picking one from 17, 25, 19, 16. We're only picking one from 20 and 21. We are only picking one from 23 and 24. And we are only picking one from 18 and 22. Okay, so that means we already have like 4 elements just from these guys, correct? So since the last one is as large as possible, the smallest value from the guys that we wrote here so far is 16. Okay, so if we it becomes as large as possible when we pick 15. It can't be no bigger than 15, so we can pick something like 15 or below. That can be the last element. Since we want it to be as large as possible, let's try picking 15, and notice that 15 belongs to the inner 3 by 3 matrix element. Let's continue the push-up first. 11, 12, 13, 14, 15. Let's go to 20. 16, 17, 18, 19, 20. Okay? So you have 15, 20. So like I said, let's try picking up 15. Okay? So when you pick 15, so since you can't pick a number from the same row or column, so you're giving up 24 in our first candidate in the first column. So let's write our numbers. So we have 15. Okay, and since we've chosen 15 in our first column right here in the leftmost column, we can only choose 23, correct? So everything in here we can't pick anymore, and again we can't pick 22 as well. It's doing it again. I think if maybe if it's open too long, I don't know. But yeah, let's proceed. So I was saying, if we pick 23, then we're giving up our choice for 22. Okay, so we sorry about that. So we pick 23, and then from there we can only pick 18 from here, right? We can pick 16 from the last column, but note that in the first row we wanna pick that 25, right? So you have these guys and these guys, and these guys are eliminated. So you have 18, and then what else? So again, like I said, I wanna pick 25 from here, right? Okay, and then so you have 25, and then so these guys are not included anymore as well, and then we only have one more pick for our last candidate. It is 20. Okay, so that's 20. Let's continue and finish the push-up. 21, 22, 23, 24, 25. Okay, and yeah, you're invited to check, but I think we've got it. I think this is the set that we're looking for. Okay, because for example, in the middle element you could have picked like something like 14. Yeah, but I think, yeah, why pick 14 when you can pick 15, right? That's like we want the minimum to be as large as possible, okay? And we've shown here that if we pick 15, which is the largest possible from the remaining set that we can pick from, we've shown that it is solvable, okay, if we pick 15. Therefore, this is the solution that we obtain. But anyway, guys, yeah, this has been day number 20 of our daily push-up challenge while solving Putnam problems. This has been Putnam from 1959. I'll see you next time. 5 more problems to go, and then we're done. Thanks for watching. Bye-bye.